Hello everyone. Today I'd like to talk about an example very similar to what this picture shows, right? Just in case that you're not familiar with this measurement tool, it's called caliper, right? So it's used to measure. It can be used to measure the diameters of a circular object, right? So like you can see, this is a pipe or maybe a cylinder or something. You can measure that the diameters, uh, and this one is also digital, right? Not only you can read from the ruler on here, right? It also has the digital readout, right? It's 31.42 millimeter, right? Of course, by measuring this diameter, you can also calculate the area of the of this circular area, circular object, right? So also you can do other things, right? And the example we're going to design is that we can use we don't have a real caliper or object to measure, right? So but we can use the HMI to simulate, right? So you can see here we can use a HMI button to input a number to simulate that, and then even though we don't have a real object and a ruler, but we can have other fancy design after that based on that. One thing we can do is that we can calculate the area by using PLC instructions, right? And also we can even set up a monitoring system, right? We can set up the upper limit and lower limit for the area, right? So if the result of the calculation fall into in between these two limits, then for example, if we are doing a quality control, we can display here, okay, this part is good, right? If it is outside of the limit, right, maybe it's too low or too big, right, or maybe there's something else, like over here you can see that you can even use a message to tell the operator there's something wrong with the setup, right? So we can have those sort of design with PLC HMI. So let's get into it, right? So so this is the interface, right? So I already explained that. Then let's look at the whole process. You already understand. Let's look at the details, right? So the calculation based on the diameter, right? So the D represent the diameter. We already know that from the math course, right? We have to get the radius divide the diameter by 2. Then we need to get a power of 2 of the radius and times pi 3.14. So notice over here, once we have this, the numbers involved are not whole number anymore, right? So they have a decimal point, right? So you can let's keep reading on here, right? The area will compare against the upper and lower limit to indicate the result. It will be not available when sensor reading is 0. Under that indicate lower than the small limit, right? And then in between and over is too big, right? So on HMI, we use the sensor simulation input. The upper lower limit also entered and displayed. There also a text message for the limit error show up. You know that that indicate we like to use animation, right? If both limits are 0 or the lower one is equal to or greater than upper, right? So if by human error, if the operator didn't set up the limit correctly, so we want to have this one show up to remind the operator, right? And this is the indicator, right? So currently it shows over, right? Of course, if you know that's a multi-state indicator, right? So that should have 4 different result, not available, under, good, and over, right? So similar to what we practice on the HMI, right? So on top of that, with this example, I also want to demonstrate, of course, the numeric tag instruction, right, for the calculations. And also, I'd like to have a UDT to design for this application, right? We all know the UDT mean to organize what we have with the PLC tags. Right? Well, I would like to show that. And also the other way is array. You don't have to use array, but with this example, I'd like to use that in our design. Of course, that relate to all the HMI setup. All right, so I'll walk through the whole process so we can go through this together. Right. So let's look at. Over here we have the PLC, and I'm gonna design the HMI as start from the beginning, right? Over here you can see I have a blank screen, right? So I'll start to design on PLC on that. If I can have maybe here, all right. So like I said, all right. So I'd like to organize my tag with the UDT. So let's work with that. Right? So start with how do we define a UDT, right? So we already have a lab on that. You already know underneath the assets, right? Data types and user defined. So if you right click new data type, so you will be provided by a screen to set up, right? So I'll just call the area calculator, right? So I'll just use this name for that, right? So that mostly we will design that represent the diameter sensor and also the result of the area, right? So with this we can of course we want I'll just use a short name, right? Diameter sensor, right? So that should have the decimal input, right? Like similar to what we saw on the picture, right? So with the decimal points, right? So and also as a result we should have area, right? So that should be a real type of data. And on top of that, if you remember that we want to display the result on here, right? So that will connect to the HMI with multi-state indicators. So suitable data type should be integer, right? Double integer. We'll just we can use the name called result, right? So then that, like I said, double integer is the suitable data type because there are 4 different states, right? So that's what we want to have. Anything else? And during the calculation, like we talk about on the formula on here, right? So there's some intermediate result, right, with the numbers, real numbers, right? So for that, that's what I'm saying on that. We have to use a I'd like to use a array, right? So it should be a real because it has a decimal point. And over here, if you click this, we can set up, for example, I don't know how many I'm going to use. I just use set up as a 5, one-dimensional 5. So over here, I use R to represent the intermediate result, right? It's a real type with 5 elements inside the array. And I think that's what we need for the for this part. All right, if we need, we can also add later on, right? So click OK. We create one. Underneath user defined, you can see here we have the air cal, right? So that calculator, that's one type. And then we also have something else we will use in the program. That'll be the limit, right? So we have upper limit, we have a lower limit. Notice there also a message, right? So there's conditions, the message should show up. So with that, I just want to demonstrate we can also have another data type. Not only one, we can design another UDT to include all the necessary tags when we work with the limit, right? So we can call area area limit, right? So something like that. So obviously we can have the lower, and we can also use real, right? Then we can have upper, also real, right? So that's two of them. And then we want to include a tag in the situation of the wrong setup. We want to show up the message, right? The message, the object itself, we can design on the HMI, but we need to have a tag to indicate if the situation need to be displayed. The message need to be displayed on the HMI, which is a animation, right? So with that, in this situation, it's better to use a bool, right? It's only two different situations, right? Either the message invisible, right, or if the message visible, right? So in different situations, so that's best suitable with a Boolean type. So I'd like to organize my members into, like, first we have a bool, then we have a double integer or real. So that's why I want to insert on here, right? So if you want, we can see we can just use a fault, right? If we use fault or error, it doesn't matter name, right? So the important is that it's supposed to be a bool tag. So we can have down here, and so we have two UDT created, and over here this is the PLC program. Right now we don't have any tags created, right? So let's just create them, right? Limit, that'll be the name to represent all the tags associated with the limits, right? So area air limit, right? That's the data type. And then we can call the so I'll just use one letter A to represent the other tag name. All right, so we want to use that to represent the area calculator. So you can see over here I only created two tag names, right? And then if you open that, right, that automatically has all the numbers we needed on there. So this is very clean way to start with the design. I'm going to start to download. That's gonna take me a while. Okay, so already download, change to run mode. All right, so let's start with that. And since we already have a tag, right, then download to the PLC, we can start to design the HMI in case if we want to calculate, right? So to simulate that, let me do that. And this is the some of the side window we can set up as the flow. If you click that, right, so you can make the screen bigger. Even for the Explorer window, you don't need that. We can make a disappear. If you really want, if you need to come back, right, so you can always press this show and hide explore window, right? So that's very good feature. So let's just see here. So let's start design the input with the input on the diameter. With this, we want to have a numerical input. So I couldn't find the object. It's over here, right? So it's a display. Let's just go around the other way, objects, right? So then we can have the numerical display, numerical input enabled. So I choose this tool, then start to create this button. So on the label, I'll just use a so you can apply. If you want to make it bigger to see if that will fit. Okay, so I'm not going to change the color. That's gonna take me like a long time. All right, so I'll just set up the connections. So with that, refresh my PLC online program, and that'll be within there. So if you click the A, so that's the diameter, right? So diameter set up, and click OK. Then we want to have a display. The display is this one. I already know that. So with this one, we want to set up the connection. That's the same tag with the diameter, right? Because that's going to show up. Remember, the polarity should leave to blank. So if you want to have a bigger one, you can make the size maybe bigger. Easy to see that. All right, and also I think that's good. That's good for the object create on there. Oh yeah, we need because it's a real, right? So we need to set up the input. So let's look at here underneath the value settings. So the currently number of digits is 5, decimal place is 0, right? If we want, we can increase, right? So example, increase to 6, and decimal point if we want to have a 2 decimal, and that should be good, right? So you can see the result, right? 3 as a whole number, decimal point as one place, the other 2 place with the input, right? So let me look at here. So monitor, right now everything should be 0, and if we test now, right, so we can use test display to quick check. That's a test display. And so right now if I click on here 1.2, let's see here. So as you can see, right, so the HMI display 1.2, also on the PLC you can see the tag value changed to 1.2, so that's good. So we have the input with the from the HMI. So now we can start to design the program. All right, so I don't need this window anymore. We can just close that. All right, so add a new run, right, with the diameter. So let me open up that, right? You can see that's the formula, right? So I'll follow this formula on here. First we need to divide by 2, right? So with that we can have a division, div, and then that will be the if you remember, the tag is called a diameter sensor, so that will be the first one. Divided by 2, if you want you can even use 2.0, right? And over here that's the reason I want to create intermediate result, because if you look at the tag, right, so we only have the diameter area and result. So with the real we only have a 2 tag. If you keep using the same tag sensor, we're gonna have a loop, right? So we're gonna have a problem with that. So that's why we need to use the other intermediate result, right? So one of them we can use the array element here, the first one, right? So we divide by 2, and then the next instruction after this will be the raised to the power 2. So I'm not sure if we have the existing, but we can always rely on multiplication, right? Multiplication is the one we can use the intermediate result times itself, right? So that'll be the power of 2, right? So that's the power of 2. Then after that, we also need the other intermediate result. So with that, we don't want to use the same tag. We want to use the next one. So in this way, it doesn't have the loop created, right? So we finish. We get the diameter divided by 2, get the radius, and radius to the power 2. And then the next one, we need to time the pi 3.14, right? So we need to use so we keep using the previous one, and then that times 3.14, and then the result supposed to be the area now. So if we get this, that'll be the result. So if I finalize, so we have the result over here. So 1.130, something like that, right? So you can do the if you have a calculator, you can verify that. I'm pretty confident I got the right answer on here. So we have the result on the PLC. Then if we want, we can display that on the HMI, right? So over here, this is only the input. Let me stop the display, right? Then we can use a we can even Control C, Control V. So because over here it's the same object, right? So I didn't bother to change the color. If you want to have a better design, of course you can do that. This one, I have the object, and then I'm going to show you this, right? So there's a set window on here, right? So you can see that's the property window, and that normally set up as the connection, right? So of course you can get other properties if you click this tab, right? But over here, I'm more interested in the connection. You can see because I copy paste from the diameter, right? That's still with the diameter sensor connection, right? So if you want to skip the browsing part, you can even type in that. So that's what I'm going to show you, right? So because you don't have to always to use the tag browser, we can even type in the tags if we know the tag name. So once we set up on that, notice here over here. That's good thing about that. We don't even need to click OK. There's no double click, no OK. So if we click somewhere else, that is already recorded. If I click that object again, you can see that's there, right? It's already recorded, saved into that place on there. So let me try it to show that. That's good. You can see here it's 1.13. That's exactly what the PLC shows on here, right? Except for we set up the decimal place, right? So this is very good start with the calculation. We change from the sensor into the area. So now we need to do something to the limits, right? So let me see here, right? So let's look at here. The limit is over here, this part, upper and lower, right? Very similar to the diameter setup, right? So that's, well, I just talk about that. We can keep using the same method, right? So you can want to have a quick design. You can copy both of them. Basically, you group them. You can Control C. Then when you Control V, you have both objects created on here, right? Because they are the same type of object we want to create. They will be the let me see what's the design, the upper limit, right? So the upper limit will be on here. So of course they are still having the same setup as the diameter, right? So then let's click on this object. So the connection on this, we can use the tag browser again, limit. So if we want to use the upper limit, right? So that's the connection and property. Even you can use that. We need to find there are lots of them, right? So we can quickly find where's the part set up the sensor, diameter sensor, which is the label, right? Caption, right? So right now it's diameter sensor, right? So we can use upper limit. Click OK. Connection. So let's find out if we can do that, right? With the upper limit. So if we test on here, test display and upper limit. So for example, if we set up 5, yeah, 5.0, right? But this one we haven't changed yet, so I just want to make sure we can do that, right? So this is 5.0 is in there. Okay, so now we can stop it and then click this to make a connection on different one. So that'll be the upper limit, and we set up this, right? So if we test, you can see here 5. That's the one we type in. All right. So we can keep using the copy paste, right? So if you want, we have 2 of them created. We can Control C and then Control V. We can have another set up on here, right? So the only difference is that we need to set up the connection on different one, right? So this one's supposed to be lower limit, right? So if we have a lower limit on here, same thing on that. You can see I click the other object, automatically bring that connection with, and also I don't need to click save, it's automatically saved, right? So the only thing is that this one, we want to get the caption. We want to have a lower limit, right? Lower limit, right? So that's the setup. We can we don't need this window for now. I just make it flow, right? So if we run it, we can set up the lower limit, right? So if for example, if we set up just 0.5, something like that, right? 5 to 0.5, you can see here, and not only it displayed on there, and then also that's the on the PLC side is also recorded on here, right? So once we have this, we can compare, right? Remember on the requirement, we want to have a result to show that for different situations, right? And on top of that, I'll finish these two. There are also 2 messages, right? Limit error and also the area, right? So let me finish this. Okay, so stop and then text object and limit there, and then you can change the color red, apply. Yeah, alright, so of course you can make it bigger if you want. Alright, so that's one object, and then I want create so create another text object to indicate this is a result of area, right? It's just a plain text object. Okay, so yeah, the side window always show up, right? So it's the important thing is that over here we want to have a result with a indicator. So that's supposed to be multi-state indicator, right? So if we create, so if you want there's so many rectangle over there, right? So maybe we want to have a circular, right, to indicate result. The default is 4 different states. That's good, right? So that's what we want. And then we want connect to the tag of the limit, right? With the limit that's no, not limit, sorry, it's the area result, right, which is a double integer, right? So that's the connection on that. So apply that. So we are way on it, so I'll just go ahead to set up the states, right? So if you remember the states on here, there are 4 of them, right? So not available, under, good, and over, right? Depends on the comparison with the limits, right? So you can set up any value correspond that, but I'll just use the default. You can see the state 0 match the value with the 0, right? So I'll just use that as not available, and when the value is 0. If it's 1, I want to use that to represent under, right? Under. And if it's 2, I want to represent the good state, and value 3 will be the over, right? So, and you can set up color if you want to have a very good design. For now, I just set up the green with the good, right? So other color, if you want, you can set up by yourself, right? So to have a good indicator here. Not very easy to see that. So maybe change it to darker, right? Apply, yeah. So that should be good. So okay, so let's go back to the PLC program on here. So we already have the result of the area. So now we can do the comparison, right? So remember that we have a different requirement, right? So let's look at the first one. So if, right, that's just EQ view. If remember that with the area, if that's 0, diameter is 0, the area should be 0, right? So if we compare equals to 0, that's the case, we can use a move instruction, right? We can, similar to OTE, right? So we can move value 0. Of course, you can use clear, right? So move to the tag that's supposed to be the result, right? So this is area. So then we can choose the result, which is double integer. You can see here, right? So we use 0 to represent the not available, right? And if we finalize, like, we can try it to see if we can. We have the the first situation when it's 0, not available, show up on the HMI. Right. So now let's move on to the next situation on the indicator. Control C and Control V, we can have this, right? So we already have that. This we can change to LES. LES, right? So if the result less than the limit with the lower, even less than the lower limit, so we want to show up as the under, right? Which indicated by the value of 1 on the result. We finalize this. Then let's try on the HMI. So if we input 1 as the diameter, right? So you can see that result changed to 1 is under, right? Result is 0.79 is less than 2. Then let's try the other way. So if we have 0 as diameter, then notice here there's a problem, right? So the problem I see is that when the diameter is 0, so let me just shut down those. Okay. So right now it shows under, but actually because the diameter is 0, we're supposed to get the not available show up, right? But we have that before, but right now it disappeared. The reason for that is that it's a common problem we need to notice, similar to double coil, right? Because this run is after the 0, right? So you can see on run number 1, this is true. We should be able to assign value 0 to the result. But on the run 2, this length instruction is also true. So that's why the value 1 overwrite the result as 1. So that's why you see under, right? So with this, if you want to get it fixed, we need to change the instructions. Right, so right now it just shows less than lower limit, and then we could, if we want, we could add another instruction to make the 0 situation exclude out from this selection. I'll show you what I mean. All right, so we can have the this run added on here, Control C, Control V, and this one we can change to JRT, and then the source A is area, source B we can change to 0. So in this case we eliminate the 0 from the condition, right? So then that shouldn't cause the double coil problem, right? Of course you can have other solution, right? You can also have the you can try, all right, but over here you can see right now, yeah, I fixed that problem. Not available, show up. Right, if I have the input as 1, we should see under. Right, so that's a good result with the first 2 situation. So now we can continue use this Control C, Control V. Right, continue to do with the other 2 situation. So with this one, we want greater than the lower limit, right? So we can drag and drop greater than lower limit, but less than the upper limit, right? So we can even change that to less than LEQ if you want. LEQ less or equal, right? So that's what we can have on here. And then if we have the last situation, Control C, we can use this Control V. So if we have a greater area greater than the upper limit, drop to the wrong spot, right? And then we can have the the value I haven't changed yet, right? So this one is supposed to be 0, 1, 2, 3. This is 3, and this one is supposed to be 2. All right, so finalize. So right now it's under 0.79. If we change the input 2.5, let's see, 4.991, right? So that's good because it's less than 5, between 2 and 5, right? So then let's increase that to 3 diameter. That should have over, right? So let's try again, right? If it's 0, that should be non-available. If it's 1, should be under, and 2 is good, and 3 is over. Then we have that. All right. The other thing is that we want to have animation with the limit error. So with this, we have a tag. If you remember, here we have a tag called the limit fault, which is a bool. So that's why we need to use OTE. So with this, we can have the condition if both limit are 0 or they didn't set up correctly. Let's look at the first one, right? So we can use EQU to upper limit equals to 0. Control C, Control V. We can use the lower limit also to 0. If, like at the beginning, haven't set up, right? You want to give a operator a warning if the limit haven't been set up yet. Right. So with this, we have to set up the animation on here. So right click, animation, visibility. So with this, we can set up the tag underneath the limit fault. Right. So when the fault is true, the OPR expression true, right, is visible. That's right. So we can apply, close, right? So if we try it, right now it's good, right? So if we set up both at 0, they simulate at the beginning. So if we didn't set up the here limit error show up, right? There are also a situation if we didn't set up the number correctly, right? So if lower limit is supposed to be less than the upper limit, right? So if it's that, we can do a parallel. So then we can do the other comparison, right? Control C, Control V. So we can greater or equal, and this one's supposed to be the lower limit, upper limit, right? So if the lower limit is greater or equal to the upper limit, that means it didn't set up correctly. So for that, you should also get a fault. All right. So For example, all right, upper limit, if we set up as before 5, we can set up 5, and then notice here that limit error disappeared, right? Of course, if you want to separate that, if either one of them is 0 is fault, you can also do that, right? So let's just do that, right? So for example, if we add level here, so we can do it on here, and if any of the limit is 0, we want to show the error. So that should show up now. Yeah, that should, because right now the lower limit is 0, right? So for example, if we set up as a 2, then that should disappear because that's correct setup, right? And but if the lower limit, if we set up as a 7, right, so that's a wrong setup, then you got a fault. Or if you set up the limit as a 5, same as the upper limit, you should also have a fault, right? You can only set up in the correct way in order to make the limit error disappear. Okay, all right.